Guys, happy Thursday. Sorry again, I'm not there in person. But we'll motor on regardless and get through as much of this geometry as you can. Just a notice that next Thursday, so this day next week, all the second year maths classes will have a test on geometry. So what you'll have is a test. If you go into the folder now, you've geometry 1, geometry 2, and what we've been doing for the past week or so, geometry 3. So we're going to try and finish off with this as best we can, and the next week we get ready for the test. It's going to be a short class test to get a number then a paper for your second year maths so far. Okay, so what I gave you the last day was I asked you to do as many as you can. So here it is here, 24.4, as many as you can. And it was all based around Pythagoras. So if we take any of these here, what you're doing, so you see there you have part 2b. And what you have then is you're looking for the hypotenuse squared. So in this case, we don't know what the hypotenuse, because remember, it's the side facing the 90 degrees. So it's not coming up, hang on. Side facing the 90 degrees. Hang on. So the side facing the 90 degrees there, so it's not going to be the 7 or the 24. It's going to be this side here. So it's going to be that side there. So we don't know what that is, so we're going to call it X. Okay, so it's not syncing for me from the iPad for whatever reason. But so if we call that X, it's going to be X squared. Well, there we go, it's coming up now. It's going to be X squared is equal to, so we call that X. It's going to be X squared is equal to 7 squared plus 24 squared. So always, Pythagoras is always the same. Whatever the hypotenuse is, there's X squared is equal to one side squared plus the other side squared. And you work that out. For part C here, here's your hypotenuse here. Call it X again, call it H, call it whatever you like. But it's going to be the hypotenuse squared is equal to one side squared plus the other side squared, like so. And you're going to work out X then every time. Okay, so some people would have gotten the first 2 or 3, as far as 2 or 3. Some people would have went on and got right down as far as number 10. You got some difficult ones there that are hard to work out. We're going to have to take a class or so to work through the next day, but it's the same thing. Hypotenuse squared is equal to one side squared plus the other side squared. So what I've done is, out here on the right hand side, and the teacher might pause the video now in a second and give you time to look at your answers, look at your solutions, see where you went wrong and correct your answers. So out here I've put the solutions to all the questions out, and you can see there's ones where you had to get the square root of to find H. So all down I have questions 1 to 10 done. So it's going to take you a couple of minutes to correct all your answers, and any ones you couldn't do then, give them a shot. The more practice, the better on Pythagoras. We're going to move on to one more concept today, and it's the concept of the circle. So when the video starts playing again, we're going to have a look at the circle after you finish correcting your Pythagoras. So, circles. And I know you know a lot of this already, but we're going to go through the kind of terminology used around circles. So, a circle, basically, is a set of points on a plane that are all the same distance from a fixed point. So if we have our clock here, here's our center of our clock, right here where all the hands are connected. See the orange dot? And if I'm to draw a line from the dot to the side, there's a point. Or from the dot to this side, there's another point. Or from the dot to this side, there's another point. That's what that definition means. Set of points in a plane that are all the same distance from the center. So that point there on the right is the same distance from the center as that point on the left. Okay, a couple of the words you might have heard before, and I guarantee you've heard these before. You've heard the word radius. So the radius is, you see it over here, is the distance from the center of a circle to the outside, to any point on the outside. So there's one radius drawn there, I could draw another one. There's another radius. There's another radius. There's another radius. Any one from the center to the edge. The plural of radius, so I've drawn more than one radius there, is radii. A chord, so the second definition there, so this chord is a point or a line from any part of the circle to the other part. See this chord here? You can see it you can see it drawn in there. So it's from any point in the circle to another point. So I can draw a chord there as well. There's another chord going from that part to that part. And then this one here is very important. See this one in the middle here? We call it the diameter. And the diameter is a chord as well. Difference is it goes through the center of the circle. And one thing you're going to need to remember, if the diameter goes from one side to the other side, and a radius goes from the center to the edge, then the diameter is going to be 2 radii, or the half the diameter is going to be the radius. So if you have 2 radius is going to be equal to the diameter, or half the diameter is going to be equal to the radius. Yeah, I guarantee you probably know that already. Okay, a bit more. The length around the whole circle is called a circumference. So if you were to have a circle and you were to start over here and you were to run all the way around the outside of the circle and go back to the start, that would be the circumference. A tangent is any line. I'm flying through these because I know you've done these. I know this is done in primary school maths. So a tangent is a line that touches the circle at a particular point. So you see over here, we have a circle, and there's a point on the circle. There's, remember, a radius, and the tangent just touches that point. So here's our tangent down here. We call the tangent maybe the line L, and there's our tangent there. So it's outside the circle, touching the circle. Semicircle, come back to a sector later on. A semicircle is half a circle. Okay, so there's the diameter. So if I were to highlight the semicircle, there's the diameter, or 2 radii, and here is a semicircle. So the bit in orange there is a semicircle, or half a circle. A sector, I said I'd come back to it, is a bit of a circle. So we have, see the green part here, the green part here is a sector. So we draw an arc and 2 radii, and the bit inside the arc and the 2 radii is a sector, and you'll see these in your answering questions. Okay, couple of rules you're going to need to remember. Couple of rules. Again, you have this video now. If you want to watch it 3 or 4 times and go back over all those diameter, radius, chord, sectors, all that kind of stuff, you can do that. This is one that you're going to have to look out for when you're answering questions on this. Each angle in a semicircle is a right angle. Okay? Each angle in a semicircle is a right angle. Okay? So if we have a look at this semicircle here, this one down here, right? So there's our semicircle, half our circle. So have a look inside there, and we have a triangle drawn, and there you have your 90-degree angle. What I'm trying to say, and I'm just going to go out here to the right for a second. I'm going to draw a random rough circle, okay? That. I'm going to draw a line through the middle, or close to it. And there's our point in the middle. And what I'm going to do is I'm going to draw a random triangle. So I'm going to take a line from here, from that point there, and I'm going to bring it to the edge of the circle. It doesn't matter where, once it's straight, and I'm going to bring it back like that. And what I want you to always remember, that when you have a triangle drawn, when it starts at one side of the diameter and ends at the other side of the diameter, this angle here is always 90 degrees. Always, always, always. So on the other side, say I draw one and I go right over here, like that. And then I go down to the diameter. It doesn't matter. That is still going to be 90 degrees. Okay, so you can see here, the diagram shows a circle with center O. Find the angle A and the angle B. Well, this is your diameter here. So you can see the line goes through the diameter. If this is 40, we can work out the other two angles. We can work out the other two angles because we know if it starts here, there's our diameter, going from left to right. The line goes to the circle and back to the other side of the diameter. We know that angle A can only be 90 degrees. And you know that all the angles in a triangle add up to what? 180. So we have 90 and 40 are going to give you 130. So 180 minus 130 are going to give you 50 degrees. So B is going to be 50 degrees. Like so. Okay, last one, just to show you that rule one more time, because this is a bit more of a right angle triangle ABC is constructed in a circle, right? We have a right angle triangle constructed in a circle. Identify what line segment is the center or the center of the circle lies on. Okay, so where does the center of the circle lie? Okay, so we have A here and we have C here, and they've told us that this angle here is 90 degrees. Okay, so we have a look at that circle. Which of those line segments is the center going to be? It has to be this line segment here. And why? Because where does the 90 degree angle fall? It falls there. So if that's our line segment, this here is our semicircle. So I've drawn the semicircle with the diameter in. We don't know where our center is, but it's probably somewhere about there. And then we could work out the angles. If they asked us to work out the angles, we could work out the angles. And they said for part B, so the answer for part A then is going to be the line AC. And for part B, use the theorem of Pythagoras to find the length of the diameter of the given circle. So we call it X, we call it whatever you want, or H. So we're looking for that side there. So if we remember the theorem of Pythagoras, remember where's the hypotenuse? Opposite the 90 degrees. So we're going to have the hypotenuse squared. So x squared is equal to 1.2 squared plus 3.5 squared. Okay, so remember the hypotenuse squared is equal to first side squared plus second side squared. So it doesn't matter which other side you take first, it doesn't make any difference. And you can work that out from there. So what you're going to do is find out with 1.2 multiply by 1.2, or 1.2 on your calculator, hit the x squared button. What's that? Squared. And that's going to give you x squared is equal to something plus something, and then get the square root of your answer to find out what x is equal to. So you can see there we're mixing in circles and triangles, and then we can work out Pythagoras theorem. So we need to know all the different rules, and it'll all come together then to in geometry questions when it comes to junior cycle exams. Okay, I know there's an awful lot in that, and you can have another read over that, or you can watch the video again for the explanations. But what I'm going to get you to do is go back and make sure you have a lot of practice done on Pythagoras. There's lots of questions there. And what I want you to do then for homework for Friday is the highlighted questions in the OneNote. So it's exercise 24.5, question 2, question 4, question 5, and question 6. So I'll put that out on the right hand side here. So homework for Friday, exercise 24.5, question, what did I say, 2, 4, 5 and 6, 2, 4, 5 and 6, 2, 4, 5 and 6. Okay, so work on your Pythagoras, have another look down through all the theory around with the circle, try those 4 questions, and what we'll do tomorrow and Friday is a recap of all of Geometry 3, and then next week, Monday, we'll go over we'll put Geometry 1, 2 and 3 together and do the little test on Thursday to see how much you're understanding and where we go from there. Okay, thanks, mind yourselves.